This is one of the biggest mysteries in modern astronomy, and the more scientists study it, the stranger it becomes. The fact is that the James Webb Space Telescope continues to find objects that, by definition, shouldn't exist. We're talking about supermassive black holes discovered in the very early universe, so early that scientists still don't understand how these objects formed. To understand the scale of the problem, we need to start at the very beginning. After the Big Bang, the universe was filled mostly with hydrogen and helium. Gradually, under the influence of gravity, the first stars formed. When these stars died, they could turn into black holes. It all seems logical, but there's a problem. Black holes that form after the death of stars typically have masses of several tens of solar masses. Even if they begin actively devouring the surrounding matter, it takes a very long time for them to grow to gigantic sizes. Now imagine astronomers' surprise when they discovered black holes with masses billions of times that of the Sun, when the universe was less than 1 billion years old. According to existing models, they simply shouldn't have had enough time to grow so quickly. This is where the James Webb Space Telescope enters the picture. One of its main goals was to study the earliest epochs of the universe's existence. And because Webb is capable of seeing extremely distant objects, it literally peers back billions of years. Scientists hoped to find answers. But instead, they found even more questions. From its first years of operation, the telescope began finding astonishingly bright and massive objects in the early universe. Some of them existed just a few 100 million years after the Big Bang. Each new discovery only deepened the mystery. How did they manage to form so quickly? Today, there are several possible explanations. According to the first hypothesis, some black holes may have formed not from stars, but directly from enormous gas clouds. This scenario would immediately produce an object with a mass tens or even hundreds of thousands of times that of the Sunday. This would significantly accelerate further growth. But this idea has its difficulties. Such a process requires very specific conditions, which could be extremely rare. There is another theory. Perhaps the first stars in the universe were much more massive than today's stars. After their death, they could have left behind much larger black holes than we observe today. But even this model doesn't yet explain all the observations. And then another interesting idea emerged. What if black holes in the early universe grew faster than our current calculations allow? If young black holes could consume matter at an unusually high rate, this would help explain their incredible sizes. The problem is that there is no direct evidence for such a process yet. This is why each new photograph by James Webb arouses great interest among scientists. At stake is more than just the history of individual black holes. If current estimates are correct, we may have to revise some of our understanding of the formation of the first galaxies and the development of the early universe. These are fundamental questions in modern cosmology. The history of science shows that the most important discoveries often begin just like this. First, an object appears that shouldn't exist. Then, new data emerges. Then it becomes clear that the old explanations no longer work. Astronomers may be at precisely such a point today. The James Webb Space Telescope was created to help us understand the origins of the first stars and galaxies. But instead of simple answers, it continues to uncover new mysteries. And one of the main mysteries is that supermassive black holes appeared much earlier than scientists previously thought. If future observations confirm this definitively, researchers will have to explain not only how these objects grew so quickly, they will have to explain why the universe was able to create them almost immediately after its birth. And perhaps right now, we are witnessing the beginning of one of the most important scientific discoveries of our time.